Today I'm going to have a go at unravelling the mystery that is the envelope plot, and we'll also look at producing ensemble statistics tables using the min, mean, max process. In a time series graph, you can put data inside an envelope that shows the behaviour of that data across a much wider time range. Let's take a look at one now. This is a graph of groundwater level. The blue trace shows the groundwater level at a site measured over the past year. The green area is the envelope, and this shows the groundwater levels at the site over the last 10 years. The green band is the region between the minimum and maximum values over 10 years, and this dark green area is the region between the 20th and 80th percentiles. You can see how a graph like this is useful to show how the water level in the current irrigation season compares with previous years. Let's take a look at how to build an envelope plot. We go to Graph, Graph over Time, select our measurement. Let's have a look at flow data this time. Select our time range, and I want to look at a particular 6 months. Now go to the Envelope tab. Here we need to select the type of envelope statistic, and I want mean daily extrema. We select the time range for the envelope. This is usually all the available data, and that's what we'll use here. So what we've got is this blue trace, which is our 6 months of flow data plotted along the horizontal axis. Then we've got this green region, which is the mean daily extrema. So what Hydro has done is taken the smallest and largest value in each day over the 40 years of data, and then computed the mean of the smallest value for all the January the 1st, all the January the 2nd, and so on. Then it's done the same for the maximum values in each day, resulting in 365 sets of statistics. This is then plotted as a histogram over the top of our selected data. You can see here that the flow in the winter of 67 was less than usual. Alphabet River is located in a fictitious Canterbury where the nor'wester comes through in spring, and you can see here that there is more water available at this time of year. And for the person out there that just has to know what happens on a leap day, we interpolate a value that's the average of its yesterday and tomorrow so as to not skew the graph. There are 12 different types of envelopes available in Hydro, and I'm going to explain the differences between them. In hourly extrema, Hydro finds the smallest and largest value in each hour of the data in the envelope. Similarly, for daily extrema, Hydro finds the smallest and largest value in each day of the data in the envelope. And you can apply the same principle to monthly extrema. I talked about mean daily extrema in the graph we drew, and you can also have a mean hourly extrema and a mean monthly extrema. The mean monthly minimum and maximum is what the Met Service use when discussing air temperature ranges. You can also have an extrema of hourly means, not to be confused with mean hourly extrema. In extrema of hourly means, first Hydro computes the average across each hour in the selected time range for the envelope. Then it finds the smallest and largest average for each hour, and it will therefore show the smallest and largest hourly mean for 6 AM to 7 AM, the smallest and largest hourly mean for 7 AM to 8 AM, and so forth. There is also extrema of daily means and extrema of monthly means. And lastly, but certainly not least, we have ensemble statistics. These are the most complex but also the most useful, and this is what I used to generate the graph of groundwater you saw at the beginning of the video. There I used ensemble monthly statistics. First, Hydro applied a probability density calculation to each month, then it computed the minima, maxima, mean and percentiles for each month. I used the 20th and 80th percentiles in that graph, but you can enter different values here and they don't have to be symmetrical. For example, you might put 10 and 50 to look for periods of low flow. If you take vertical axis as percentile, Hydro will express the data in terms of percentiles from 0 to 100, which, in effect, removes the seasonal variation of the envelope, so you can view the data in relation to the envelope. You can add the envelope mean to your graph by ticking here. You can choose to center the envelope, which draws the envelope as a set of instantaneous values rather than a histogram, which has the effect of smoothing the appearance of the graph and makes it easier to identify trends despite not being so mathematically rigorous. I used this function for my groundwater graph. Like with everything in Hydro, you can select your own colours here if you want to. One last thing I'll mention is the Start of Graph button. This will end the envelope calculation at the time when the data you have chosen starts, and this means that the data in the graph is not part of the envelope calculation. You can produce tables of ensemble statistics too, and to do this, you use the min, mean, max table. The first lot are fixed interval options, and I talk about these in the tables video. You can produce tables of ensemble data, and I explained these options in reference to drawing envelope plots. Let's have a look at Ensemble Daily Extrema. This option sends the data straight to the Windows clipboard so you can paste it into Excel in the light directly. Our Ensemble Daily Extrema table lists every day of the year and reports the lowest value found from all the January the 1sts in the time range, the highest value found from all the January the 1sts in the time range, and the mean value for all the January the 1sts. And there we have envelopes and ensembles. I hope that shed some light on it for you. Thanks for watching.